Welcome, everybody. This is the KubeVirt community meeting, February 12th, 2020. First on the agenda is a demo from Keith, so I will turn it over to him.
All right, thanks, guys. My name's Keith Schinke. The last few weeks, I've been working on a request to implement a IPMI method to manage KubeVirt virtual machines. So with this, a user will be able to send like a IPMI signal to manage an instance and cause a KubeVirt event to happen to manage that VMI. So I've got, I leveraged the virtual BMC existing application that OpenStack uses and extended it to work with the KubeVirt Kubernetes API. So let me see if I can share my desktop. And I just had a thunderstorm go by, so hopefully my power doesn't flicker. But if I suddenly disappear, that's hopefully what it was.
Live demos are always more fun when they're risky.
Yep. Okay. So hopefully you can see my screen. Some of the issues I had, the virtual BMC from OpenStack is in Python. And that was not my first language, but nobody uses Perl anymore. So I'm learning. And then I extended to use the Kubernetes API, and I used the KubeVirt Python library to make my API calls. I've got a couple of repos that I'll put into the notes after I'm finished. And then the major features I implemented was start, stop, and set boot device. Because these are directly mapped into API calls from the Python library. And then the setting boot device, I'm able to manipulate the VM definition for a pod, for a virtual machine, to set the boot device for the next boot up. And I'll go into more details about that. Some things I couldn't implement was queries to the running VMI, because I couldn't get the Python library from KubeVirt to work. It was throwing some deep error when it tried to unserialize stuff. And then soft shutdown and reset, there's no matching API call for that. My development environment, I use a desktop underneath my desk, Fedora 31, and I try to stay pretty fresh on the Kubernetes with Minikube, and I use the latest KubeVirt. It was 24 when I started, and I stepped through 25 and 26. So I've been following along. The one thing is a PV for mapping in the configuration file needed for running the virtual BMC. So you can set the mode and where it saves its files from one run to the next. And then I also populated the kubeconfig file because I was making it work. So I can demonstrate that if need be. And then to make it load, I have a configuration file that creates a pod. Let me copy this. Here I'm watching my resources on this screen. And then here I can load it. Except it's a live demo, and of course something goes wrong. Oh. There we go. My container should create pretty quickly. So we have it running. My client, I actually built into the pod itself. So I can use kubeexec right now to add new IPMI interfaces to query the status and to start and stop them and delete them. And then to actually manage a VM, a VMI, I use the IPMI call. So in this screen, I'm using the demo test VM that's provided by KubeVirt. It's not running and my pod isn't outputting any logs. Cuddle. So I issued my list command. This shows that there are no listeners provided right now. I can do an add command, and the name is the name of the VM instance. The namespace is the namespace that it's running in, which for this case is default. The port will be the IPMI listener port. It defaults to 623. I'll make it 6231 for the case of this demonstration. And then you need a name so that you can keep track of it through the virtual BMC. You could call it Bob or anything like that. I just try to keep them consistent. And now if we do that list, you see that we have one listener configured and it's not running at this time. Keyword. So what this shows is the IPMI listener is running, but if I go back over to here, the VM is not running and there's no VMI resource. But we can see the output of the commands on this pod to see what's going on. Now the pod bound to the host network. So this IP address is the IP address of the node that it's running on. You can get that with the kubectl describe. I just happen to have it in my command history. And then I'll issue a power on. And what this is going to do is it's going to send an IPMI event into the pod. It's going to receive it. It's going to find the matching configured configuration file, set it to on, and then it has an event listener that every once in a while polls all of the configured ports and changes their status based on the file. And so we see that we received the power on for the domain test VM. It became running, and then we saw scheduled, and now it's running also. I can issue a start. I can issue a stop. I can change the boot device. Now this follows the same methodology that the virtual BMC does from OpenStack, and the fact that when you set a boot device, it will set it in the KubeVirt BIOS. It doesn't follow the IPMI convention where you say, well, I want you to boot off the network once. No, it unsets any previous boot device and sets the network as the next boot device. I can demonstrate that. I just don't pixie boot. It'll sit there and try to pixie boot and then fail. Let's see here. And then power off works. You see that we see a power off, and then the machine's going to go through the shutdown phase. The other commands that we have a show command, which shows the configuration of a test VM of a configured listener. One issue that I'm found this week that I need to troubleshoot is the port isn't being printed by my client. It's being sent from the data from the server side. Something's happening on the decode of the JSON. I just need to figure that out. That's why I just happen to remember that it's 6231. And then that's about it for my demonstration.
Very cool. So when we're looking at the screen right there, where it says
Yes.
Start Test VM, this is, of course, completely unfamiliar to me in terms of interface. That's not starting the VM. That was starting the listener that was associated with the VM, right?
Correct. That's starting the IPMI listener. So when you create it, when I did the add, it configured a listener, but it doesn't start it. So it's not ready for IPMI events. And then when you issue the start, the Virt BMC daemon actually forks off a new version of itself. The new one's listening for IPMI events on the configured port. That one is able to issue the API calls down into the Virt API, your KubeVirt API, to make things happen. And then, if I issue a stop, this is going to shut down the listener in a couple of seconds once it happens. And then if I issue the IPMI command again, it's going to error out because there's nobody for it to talk to. So yeah, that start test VM doesn't start your virtual machine. It starts the IPMI listener. Yeah, this is going to error. So there we go. Any other questions?
That's pretty nice work. Nice. What do you plan to do with it?
We have some users who want to use this in their lab because they have tooling that uses IPMI to cause failure events to happen as they're doing CIs or validation tests. They're wanting to move from OpenStack to OpenShift, so they want to keep their same tooling and similar workflows as they change environments. So that's primarily why I wrote this. While trying to merge in some of my work into my own GitHub, I accidentally made a merge request for upstream, and there's only like 5 lines difference that I need to change from where they drifted. Otherwise, it's a clean merge upstream for the server portion. My Go-based client, which does the show, list, and add and stop, it needs some more polishing. Obvious one is this port number that's not showing up. And the virtual BMC uses ZMQ messaging to pass messages from the client to the server. If there's communication issues, I get a success when I actually didn't get any data. So I want to change that up to something RESTful so I can get better failures out of it, better interfaces and things like that. And then we'll just see what users want after this.
Yeah.
So Fabian, one of the original intentions behind this is people were asking to be able to run MetalCubed on top of OpenShift. So this would allow the QE to be able to run MetalCube strictly on OpenShift without having to set up VMs ahead of time.
Yeah, that would be really nice. Yeah, I ask because I wonder where we could take this, right? So I think, like you mentioned already, you're executing the commands inside the Virt BMC operator, for example, to add the test VM, right? And I wonder if this could be made slicker in some way. Because in the end, I think that's a really nice add-on for KubeVirt. And I'm just
I could make it nicer. I didn't want to expose that ZMQ port to everybody. If I made this into a RESTful type app, then I think it could fit better into the rest of the ecosystem. But that's going to take, some knowledge on my base and some changes in the code.
Yeah. Yeah, I think what you could also consider is actually, considering to have a config map that your operator is reading the all the VMs from, it should be managing, or if the operator is watching all VM entities in the cluster in general, to do the kind of management.
Right. I didn't want to do all VMs. That's a design option. Because the port needs that port number, that 6231 needs to be unique per virtual machine you're managing. I can configure this name and password per port when I make them, but the event that receives those IPMI calls doesn't know which user called it. So I looked at that and experimented with, I just used the same port and used different usernames. My receiving stub never knows which user it was. It's an authenticated user. Go do this event.
Okay. Yeah, that is, I would call it a security issue.
Yes.
Yeah, but then I think, one thing, I think, not going too much into the detail, but I think, tying, enabling the user to leverage the IPMI tool and only the kubectl tool, I think, or I really wonder if we could make, it slick to expose VMs which should be, or to annotate or mark, label, whatever, VMs which should be manageable via IPMI tool. So for example, I could also imagine that you put a certain annotation on a VM in case that you want to expose it via the IPMI tool, because then I think it becomes easier from the operational side or configuration side. In general, by the way, the use case is great. I really like that. Yeah.
Okay. I'm open to ideas, and then, just point me to the knowledge I need to learn. I can implement them. I want to make this frictionless for users to use as much as possible.
Yeah, I would suggest that you maybe write a summary email with this POC and maybe a pointer to this recording to the mailing list, and then I would at least share my thoughts there, and they're not lost.
Okay.
Cool. Kudos. Nice.
All right. Thank you.
Oh,
Yes,
I think
very
we
nice.
thank you.
All right. Let me hand it back to Stu.
Sure. Well, that was the only agenda item so far. Is there anything anybody wants to add today? All right. Well, thanks everybody, and see you next week.
Thank you. Bye-bye.
Bye. Thank you for